The sum of two numbers is 6 times their geometric mean. So that's your equation. Show that the numbers are in the ratio of, okay. So we have to prove a particular thing. So we can talk about this actually. Let the geometric progression numbers be a comma a into r, where a is the first term and r is a common ratio. So once we have this, then we can talk about what is that we need to prove. So we have the first term and the second term is equal to 3 plus 2 root 2 divided by 3 minus 2 root 2. Now the proof. So they have been given the following actually. So we have been given that sum of the two numbers a plus ar, right, is 6 times a geometric mean. This has been given. So what can we do with this? And this is nothing but ar. So geometric mean between two terms is square root of product of those numbers, is it not? So a bit of simplification, that is, I'm going to take a common over here and I have 1 plus r, that's equal to 6 times of square root of a square into square root of r, right? So using the identity ab whole to the power of n, which is a to the power of n into b to the power of n. So this and this gets cancelled and we have a times of 1 plus r, it's equal to 6 times of a into square root of r. So what can I do over here? Well, a and a is common, we can cancel that. So we have 1 plus r is equal to square root of r. So to simplify this, I'm going to square both the sides. And so we have a square plus b square plus 2ab, and on the RHS we have 36 into r. Okay guys, again, such steps you need not write. No harm in writing, but it's a waste of time. So what would I like you guys to do is directly express it in this way: plus minus 36 minus 34r plus 1 is equal to 0. If you are able to. If not, yeah, you can write this step and then this step. Okay, again, just a piece of advice. It's left to you guys how you do it. So this is the quadratic equation which cannot be solved with splitting the middle term clearly. So we'll make use of quadratic formula. So as per quadratic formula, what do we have? So we have r is equal to minus b plus or minus square root of b square. Because it's square, I'm neglecting the negative term, but yeah, I mean, I wrote it so that you guys are not confused. 4 into a into b, so basically it's 4 divided by 2a. So 2 into a. Then what else we have? We have, okay, so this is what we have to simplify. 34 square and all of that, I don't remember. 34 square, 1157 6, so 1152. So 34 plus or minus 1152, right? Yeah. Divided by 2. So this we have to prime factorize. 1152, we have 2, 5, then we have 7 and 6. This is 2, this is 2, 2, 8, 8, and this is 2, 1, 1, 4. Okay, this is nothing but 12 square. 12 square, then 12, then 2 square, that's 24 square into 2, basically. Okay, so I'm able to rewrite this as 34 plus or minus square root of 24 square into 2. This entire thing divided with 2. And then we have 17 plus or minus 12 root 2. Again, I skipped a step. Right? I have used AB whole to the power of n, which is a to the power of n into b to the power of n. I'm applied the square root individually over here. So basically I skipped the step. So it was square root of 24 square into square root of 2. So this gets cancelled and divided with 2. I have directly done it. Right? I had a division with 2, right? So I got this answer. Again, learn to skip steps. So basically by doing mental calculation. So we have r value. And we know that this and this will get cancelled. 1 by r is equal to this particular expression. Right? So that's your LHS basically. Okay, so where did we start off with? So this was our LHS, to be honest. I mean, this was given and we have our LHS, right? We got the expression for R. We just have to prove this to be equal to this and we are done. So for that, I'm going to take the RHS. So we have 3 plus 2 root of 2 divided by 3 minus 2 root of 2, right? So I'm going to multiply and divide with, let me do that with, yeah. So let me kind of multiply and divide with, I think in the denominator we will need, okay, let me do this. So just rationalize this. So what will we end up with? We have a plus b the whole square, so a square plus b square plus 2 into a into b in the numerator, while in the denominator we have 9 minus 4 into 2. So this would be 8 and 1 basically. So this is a simple final expression. So we have 8 plus 17 plus 6, 12, and we have the same answer, right? We're almost done. So we have r is equal to this expression and this particular expression solved to this. So what I can do is I'll rearrange this actually. So we have ar by a. I can take it the other way around also. Okay. So this is our RHS and clearly our LHS is, we just solve that. So our LHS is a by r by a, so which is equal to r, which is equal to 17 plus 12 root 2. This is one of the expressions, possibilities. So comparing 1 and 2, what do we end up with? So from 1 and 2, we have the LHS is equal to RHS. Okay, this is one of the possibilities and that's good enough, right? They show that the numbers are in the ratio of, so I can take these numbers to be in this ratio. Is it not? So basically, I started with the given. I simplified it by using a plus b the whole square, and then using quadratic formula, I found the value of r. So once I know r, well, my LHS and RHS, the expressions are relating r with the given expression. I simplified this separately and I could see that both are one and the same. and we are done. So this is all basic exponential and everything. Again, if you are weak with this, you need to work on your exponent from math basics.